So now in the agriculture, there are lots of advances have been happening, especially on the crop production side. The first and foremost, I would like to tell is about the response farming. Like previously, we used to have a lot of activities without considering weather as one of the input. But now, because of the changing climatic condition, people are giving utmost importance for the weather. So as far as weather is concerned, we have got a lot of forecasting improvements done in over the past few decades, especially in the recent decade. We have got a lot of improvement made over the weather forecast. Gone are those days when the people predict rainfall, forget your umbrella and you can go into the go out like that. But now people are looking at the weather forecast information for everything. As far as agriculture is concerned, the agriculture is highly dependent on weather. Not even after seeding, even before seeding. For land preparation, we require rainfall. So, from the pre-sowing condition till harvest, even for the post-processing and transport, it is everything is controlled by weather. So, if the weather is perfect, you can achieve 100% potential yield. If the weather is not perfect, definitely you're not going to get the potential yield. So depending upon the prevailing weather conditions during the crop growing season, you will get the yield. So that's why weather plays a crucial role as far as agriculture sector is concerned. So for weather forecasting, we have got a different kind of weather forecasting. Now people have got the seamless weather forecasting kind of things. Seamless means first they will look at the seasonal climate prediction. If the season is going to unfold as a good season, they can go with good varieties, they can go with high inputs, and then they can reap the maximum harvest. That's where the seasonal rainfall prediction helps it. If the seasonal rainfall prediction is given as below normal rainfall, so naturally the farmers have to become very cautious and then they have to choose the drought hardy varieties. One problem with choosing the drought hardy varieties is the drought hardiness is always combined with the low yield. So we have to be very careful in choosing the variety. At the same time, choice of inputs, all those things need to be very careful. Not only that, if the weather forecast is going to be lesser than average rainfall, they have to go with the lesser water requiring crops and rather than choosing a high water requiring crops. So this kind of one time decision which cannot be altered during the course of cropping, that has to be taken based on the forecast information. So that is where the response farming lies. The second kind of forecast is, it is the medium range forecast, wherein the tactical decisions could be taken based on the medium range weather forecast. If the farmer wants to irrigate, he needs to know whether it is going to be raining or it is not going to be raining. If it is expected as a dry season, naturally the irrigation has to be scheduled. Similarly, plant protection. For example, if you are going to get heavy rainfall in 2 or 3 days time, you don't have to spray plant protection chemicals against the pest. Because of the intensity of rainfall itself, the pests will get washed away. So these kind of things will lead to environmentally protected or environmental safe cultivation. At the same time, reduce the cost of cultivation and also will increase the yield. So this is what is response farming. Then the second most important thing is organic farming. Like in 1960s, we had to grow more food to satisfy the people's need in our country. Before that, we have been begging bubble, and there was a lot of hue and cry that we were not self-sufficient. Due to the introduction of high-yielding varieties and the chemical fertilizers, naturally our yield levels have been boosted, and in the mid-60s and late 60s, we could achieve the self-sufficiency in the food grain production. But at what cost? Because of this overuse of fertilizer, people were thinking when they dump the fertilizers, naturally their yield levels will get increased. So because of this, the soil got spoiled, and the microbes and all the biodiversity within the soil, flora and fauna, all those things, they got disturbed because of the overuse of chemical, and that led to low productivity. Nowadays there is a plateau in yield. There is not, whatever the inputs you are putting on the soil, it is not anymore increasing the yield. There is a plateau reached already. So the research now taken up by most of the people is breaking the the yield plateau. That's what is happening. So one such method is organic farming, which helps in regaining the fertility of the soil. So organic farming means using the natural products, natural ingredients available in the farm itself with low external inputs. So that is where is the organic farming. So we control the pest organically, we manage the soil organically. That leads to healthy food, and that leads to nutritional food. So that is where is the organic farming. This is one other advantage that is happening in this organic farming. Next one is precision farming. So precision farming is precisely whatever is the crop requires, that you are giving it to the crops. You are not overusing anything. Like I had an opportunity to visit one of the farms in Israel where it is protected cultivation, entirely controlled. It is export oriented cultivation, entirely controlled with very high precision. For example, roses and cut flowers, they have been using artificial soil with the pot mixture and so on. In each of the pot, there was a chip planted in each of the pot. So what they were doing is, it is all controlled by one computer. The chip will tell this is the soil moisture available. So they have already programmed, if the soil moisture level goes 60% available moisture holding capacity, then naturally irrigate. There was a drip irrigation for each and every pot, irrigate to that particular part, and once it reaches 80% available water holding capacity, naturally the drippers will stop emitting water. So that means controlled irrigation is given. It's exactly whatever the plant requires, that much only was given. So there was lot of water saving. Not only that, similarly, instead of giving one-time fertilizer, the fertilizer is given every alternative day in smaller quantities through the fertigation, drip fertigation, which actually reduced the loss of fertilizers and nutrients into the soil as well as into the atmosphere. Most of the nutrients were taken by the plants, which actually has given a lot of yield advantage. And there was a lot of saving in the inputs, which actually increased the profit to the farming community. So this is where is the protected farming. And then nanotechnology. Now the very recent advancement is the nanotechnology. I hope you must have been exposed to this nanotechnology. It is playing a major role in most part of the areas. As far as agronomy, as far as crop cultivation is concerned, now we have got nano weedicides, nano herbicides, and also nano nutrients and so on. So the advantage of these things are, you are using very little quantity of the nutrients, but at the same time you are actually extending the life of those nutrients, which will be available to the plant throughout its life period. So these kind of technologies are really playing a major role. These are all some of the advantages. Integrated input management is yet another thing. So today my concentration of thing will be, I will be talking about two important issues. One is, I've been asked to educate you on the system of rice intensification. Other one is crop boosters. So in general, there are lots of advantages happening or advances happening in agriculture. I'm going to concentrate on two things. One is on SRA, another one is on crop boosters. So coming to system of rice intensification. It is a climate smart rice cultivation systems for a changing climate. The climate is changing. To what extent it is changing? When we just see over 100 years of time, we have already seen that the temperatures have increased by almost 1 degree Celsius over the globe. But it is only an average temperature. The mean has got shifted by 1 degree Celsius. But at the same time, if you see the fluctuations between year to year, it might go up to 3 degrees Celsius higher or 2 to 3 degrees Celsius down also. Both are not good for crop cultivation. If the temperature goes 3 degrees Celsius higher, I'm just talking about the past temperature. So what would have happened? There must have been lot of increase in water requirement, because the evapotranspiration must have increased, and the entire system of cultivation would have got impacted because of the changing temperature condition. So this is one of the important observation we have made. There is a mean shift in the temperature by 1 degree Celsius. to tell you in a very simple words, if the temperature was 26 degrees Celsius, mean temperature was 26 degrees Celsius 100 years before, now the mean temperature is 27 degrees Celsius. You might ask, what 1 degree Celsius is going to impact the entire system? Yes, it does impact. The reason is the 1 degree Celsius increase where it is happening, either in the temperate region or in the tropical region or in the polar region. That makes a lot of changes. Now because of the increase in temperature, we have experienced so many other allied factors. For example, the rainfall pattern itself is changing, right? The number of rainy days are decreasing, the intensity of rainfall is increasing, so that leads to flash flood as well as long dry season. So there is an intermittent dry season and also flash flood, which both are not good for agriculture. The flash flood, exactly what it does is, it just takes away a lot of potential soil from the top. That leads to erosion. So lot of soil nutrient is also lost. The land become unproductive. So these are all some of the issues. When you just take into higher elevations and also the mountainous climate, what is happening is the permanent ice caps are melting. That increases the sea level. When the sea level is increasing, that also has got a lot of impact. Most of our potential agricultural productive areas are lying along the coastal line. So once the sea level is increasing, automatically all the agriculture land is getting affected. There are two ways by which it is getting affected. First is direct way, because the seawater actually come into the soil, into the land area. There was an intrusion of seawater, making the land as a saline one. The second way of impacting is secondary salinization. Under the soil, the seawater intrudes to 1 to 2 kilometer, again making the land as a saline land. So two ways. One is directly the seawater get into the land. Second is through the seepage, it actually come into the soil as secondary salinization, and it impacts the crop productivity. So there are a lot of impacts are happening. So now how this system of rice intensification is becoming a climate smart rice cultivation system, let us see that. So we have done a lot of research through one of the externally funded project. I just had an opportunity to work with the international community on the system of rice intensification through a project called Klima Rice and Klima Adapt, which was funded by Ministry of Foreign Affairs, Norway. So with that project, I was actually interacting with the international scientists, and we have been evolving so many information through this system. So let's see why this is important, right? In India, totally 44 million hectare. That's the world's largest area is under rice. The second largest rice producing country in the world is India. So the requirement of food grain means milled rice is 130 million tons by 2030. 2030 is not too far. We are in 2020. In another 10 years, the requirement of rice is 130 million tons. As far as climate change is concerned, there is a decline in water quality, increasing trends in temperature, and there is a rainfall variation. How much temperature increase is expected? Maybe 3 to 4 degrees Celsius. 3 to 4 degrees Celsius towards the end of the century, the temperature increase is expected. As far as rainfall variation is concerned, we are actually expecting both ups and downs. There might be 15 to 20% increase in rainfall, and also in few places we could see that there is going to be decrease in rainfall. As far as the productivity of rice, it is expected to decline by around 40% in near future because of the changes in these kind of conditions if we don't adapt. Okay, if you are not going to do any adaptation, the productivity of rice is going to be declined. So what is the scope? We need to increase the productivity per unit area. So per unit area, the yield has to be increased, that too in a very sustainable manner. So with this consideration, we have to have consideration on the environmental safety itself. So to all these things, we just say that climate smart agriculture is one of the practices through system of rice intensification, wherein there are triple objective is obtained. One is the climate change adaptation is done, climate change mitigation is done, and increasing food security is done. That's why SRI is called as a climate smart agriculture. How can we substantiate that? Okay, so let me just see, like climate change mitigation. Mitigation means there has to be reduced greenhouse gas emission. Then you must ask me, what are the greenhouse gases? One is carbon dioxide, another one is methane, third one is nitrous oxide, water vapor, CFC, and so on. As far as rice cultivation is concerned, because most of the rice is cultivated under the flooded condition, methane is one of the important greenhouse gas coming out from the rice cultivation. So system of rice intensification, it reduces methane emission. That's why it is qualifying as climate change mitigation. Coming to climate change adaptation, it is consuming less water. Okay, it is consuming less water compared to continuous flooded condition. That's why it is also qualifying it as a climate change adaptation. Third one is increasing food security, because compared to conventional, 20 to 30% yield increase is there. So triple objective of climate smart agriculture, climate change adaptation, mitigation, as well as increasing food security, everything is achieved through this particular method. That's why it is called as a climate smart agriculture. So to give it as a simple points, it increases the productivity, it enhances the resilience, it reduces greenhouse gas emission, it promotes carbon sequestration and increases food security. That by that it also adds to developmental goals. So that's why it is called climate smart agriculture. Let us see what are the key components of system of rice intensification. The key components are, first component is perfect land leveling. So we have to have perfect land leveling as far as SRI is concerned. The major reason is we are planting just a 12-day, 13-day old seedling, which is very thin and feeble. So if you don't have perfect land leveling, there'll be undulations, water stagnation that will actually spoil the seedling. So you have to have perfect land leveling. That is the first and foremost component of SRI. The second component is use of organic manure. We always suggest that before going to SRI, grow green manure crops in the land. Try to incorporate when it is at flowering stage, so that your organic manure usage is compensated. So use perfectly organic manure. Third one is less seed rate. Just we are using 7 to 8 kgs of seeds per hectare, because we are advocating single seedling. At the most, we are advocating 2 seedlings per hill, not more than that. So less seeds are required. So less seed rate, 7 to 8 kgs per hectare. Go with square planting. Square planting, normally the recommended square planting is with the spacing of 22.5 into 22.5. But now because of the labor scarcity, we are going with the machine transplanting. So with that, we are just saying that 25 centimeters into 25 centimeter is the recommended spacing. So both the sides you keep equal spacing. That's how it becomes a square planting, which makes it possible for the corner weeders to operate on both the sides. The next one is transplant young age seedling, 8 to 12 days old seedlings. So that is the recommendation. Very young, 2 leaf to 3 leaf stage. That is what is the transplanting stage. Then single seedling per hill. For practical purposes, maybe you can go up to 2 seedlings per hill. Less water. How can you do that less water? Instead of ponding the water throughout, you are going with alternate wetting and drying method of irrigation. So alternate wetting and drying method of irrigation, there are many advancements have come now. The water tubes have come, because even if you see hairline cracks on the surface of the soil, still under the 10 to 15 centimeter level, the soil is so wet that we could see it from the water tubes. The water tubes are nothing but the perforated plastic pipes that are kept within the paddy field, wherein you can just see how much is the water level available under the surface. So by using that, you can very well manage it, alternate wetting and drying method of irrigation. So that actually saves a lot of water. So statistically, how much water is saved, we will see in subsequent slides. Then turning backs weed into the soil. This is through cono weeding. So through cono weeding, we are just turning back the weeds into the soil. That adds organic matter content, that also disturbs the plant a little, which increases the root as well as tillering capacity of the plants. So this is how these are all the key components of SRI, but it may not be possible to follow the entire package of practice of key components of SRI. But whatever the way you can practice, how many key components you can manage, that you can also do it. That is called as a modified SRI. Okay, I was just saying, through alternate wetting and drying method, we have got water saving. So I just wanted to bring in where how much water was saved. These are all perfectly conducted experiments in China. Through SRI, there is a report that 40 to 47% of water saving could be achieved, whereas in India, through conventional method, we are using per acre 2,500 meter cube of water we are using. Whereas in the case of SRI, we are just using 1,608 meter cube per acre. So which means 40% of the water could be saved. So similarly, in Philippines, in conventional, they use 1,330, whereas in SRI, they used just 1,030, which is saving of 22.6%. You can just ask me, why in India 2,500, in Philippines 1,330 in conventional method? This is mainly because of the climatic conditions prevailing in the crop growing places. So based on that, we are just calculating the water requirement and we are trying to assess the changes. In Vietnam, 33%, in Indonesia, 40%, in Kenya, around 28%, in Tanzania, maximum of 64% water saving was recorded and then it was reported. In Mali, 10%. So this is the range of water saving that could be achieved as far as SRI is concerned through alternate wetting and drying method of irrigation. Okay, so second thing is mitigation of greenhouse gas emission, right? So I was telling to you, because we are continuously flooding the soil, so that actually doesn't permit the oxygen to go inside. So that keeps the soil under reduced condition and that results in methane emission. We could see that in China, it ranges from, in the conventional method, it ranges from 7.01 to 16.4 grams of carbon per meter square, methane per meter square is coming out. Whereas in the SRA method, it was just 1.88 to 2.47 grams per meter square. So that means there is a 79% reduction in methane if it is done in alternate wetting and drying method. Whereas in India, 38% reduction could be seen. In most of the other locations, 36% change in methane. That is the reduction in methane achieved in Thailand under different systems, under irrigated condition, rain-fed condition, clay soil, sandy loam soil. So under different soils, they achieved a 36% reduction in methane emission if we go with the alternate wetting and drying method of irrigation. But there is another noxious gas, that is nitrous oxide. There is an increase in 10% in the case of SRI. The reason is, during alternate wetting and drying system of irrigation, we are permitting oxygen at the drying time. So that reacts with nitrogen. The oxygen reacts with nitrogen and that makes the nitrous oxide emission, enhanced nitrous oxide emission by 10%. However, if we just calculate the GHC emission potential, definitely the SRI emits lesser GHC compared to the other type of cultivation. Okay, now let us see what is the comparative performance of rice under SRI and conventional method of cultivation. So in the case of comparative method, means it is how much yield is obtained. As far as SRI is concerned, tons per hectare, and conventional average percentage increase. So in India, under SRI, we got 8.73 tons per hectare on an average, whereas in the conventional 6.31 tons per hectare, which means there is a 27.7% increase in yield if we do the SRI practices. Okay, most of the countries it is more than 50%. For example, in Madagascar, where the SRI emanated, where it was 75% increase in yield was reported, whereas in most of the countries more than 60%. For example, in Tanzania, Kenya, more than 60% yield increase, and Myanmar, Philippines, it is more than 50%, Indonesia more than 40%, and rest of the countries around 20%. In Mali, again close to 40%. So this is the yield increase. Even if it is 10 to 15% yield increase, it is commendable. So as far as SRI is concerned, we have got a definite cases of yield increase. So in India, we could see that it is around 27%. So this is the comparative performance of SRI with the conventional method of cultivation. Okay, I was just telling to you, I just wanted to present our own case study. We have been doing this Climarize and Adapt project in two river basins, two basins. One is, you can just see here, this is the Kaveri basin. Out of that, one is in Kalingarayan basin. So the Kalingarayan basin it is located in the Erode district. Another one is Ponnaniyar basin. This is in between Karur and Trichy district. So this is where it is located. Why we have chosen these two locations is, Kalingarayan basin it is a water surplus basin. So by default, farmers are entitled to get water for 10.5 months in the Kalingarayan basin. Whereas in Ponnaniyar basin, it is highly water stressed basin. Here, in this basin, there are two hills. One is Perumal Malai, another, and nearby there is another hill. Those two hills forms the catchment area, and the water gets collected in a dam called Ponnaniyar Dam, where the water gets released for the irrigation. But here it is highly water stressed basin. For the past 5-6 consecutive years, this is the dam. For the past 5-6 consecutive years, they did not open the dam because the water level did not come up to the sluice. But it definitely had impact on the groundwater, and so with that groundwater, the people are cultivating paddy. So this is about the Ponnaniyar basin, which is highly water stressed basin. Whereas in the Kalingarayan basin, it is completely Kalingarayan canal. The water is available for 10.5 months. And nowadays, because of the changing climatic condition, the rainfall is highly varying, and they are not getting as in the case of earlier time 10.5 months. Now they are getting only for 6 to 7 months. So the farmers also are learning to economize water usage. Otherwise, they were not so economizing water usage. They were just lavishly using the water. Now they are also feeling the heat of changing climatic condition. So what is happening there? So what we did a case study with a lot of farmers, and these are the component technologies: land leveling, using young seedling, single plant, green manure application, alternate wetting and drying, and cono weeding. These are the component technologies. Okay, so we just grouped the farmers. As I said, all the farmers cannot adapt all the key technologies. So what we did was, we grouped the farmers based on their level of adoption. So if in treatment 1, whoever is the farmer who all have used all the 6 technologies, they come under all the 6 component technologies, they come under T1. If some of the farmers are not using young seedling, but they follow all the other factors, they come under T2. In T3, they use land leveling, single seed planting, alternate wetting drying, and cono weeding, only that much. In another treatment, T4, they just use single seedling with the green manuring. So like that. So we have got all combinations of treatments, and this is the percentage of adoption of SRI. So how much was the yield in the case of both Kalingarayan basin and Ponnaniyar basin? It is given over here. So in the case of Kalingarayan basin, if they adopt 100% of SRI technologies, the yield obtained was 9.7 tons per hectare. Sorry, here it is little mistake is there. It is 9.7 tons per hectare, and the yield increase over control was, it is 48% yield increase over control. Whereas in Ponnaniyar basin, it is only 7.8 tons, but however, the yield increase was 51%. So like that, even if they just adopt one or two technologies also, there is an yield increase up to 5 to 8% is there. So definitely we could prove that the yield increase is there in the case of SRI. So we need to promote all these component technologies. Even if the farmers are not able to adapt all the six technologies, whatever is feasible and possible, we can encourage them to go for it. So here, if you just see, this is the performance of rice under different water regimes in Kalingarayan and Ponnanayar basin. So if this is a blue one is SRI, red one is just following alternate wetting and drying, third one is conventional. So as far as the number of plants is concerned, it is lesser in the case of SRI because we are following wider spacing and also square planting. But the number of productive tillers is high with respect to SRI, and number of grains per panicle is also very high, and filled grain is also comparatively good, and also 1000 grain weight is almost equal because it is genetically controlled. And it shows a lot of advantages in the case of SRI, especially number of productive tillers and number of grains per panicle. In both the cases, it is increasing with the SRI components. And especially, we just wanted to, we analyzed the impact of green manure application in improving the soil fertility. It was soil organic matter content was 0. 0.9, whereas after the treatment was imposed, it was 0.96. And in the case of Ponnanayar basin, 0.86, and after that it was 0.95. So because of the addition of organic matter, definitely the organic matter content in the soil is also increasing. This again, it is performance of rice under different water regimes. It's again, it is a number of plants per meter square, number of productive tillers, grains and filled grains, and 1000 grain weight. So if we just see two varieties we have taken, we just wanted to see whether there is any varietal differences also there with respect to SRI performance. We could see that there is both of them are similarly, the performance is similar, but with the varying magnitude. But there is definitely an advantage over over conventional. SRI has definite advantage over conventional method. So we quantified like how much exactly is the water used in the case of conventional, in the case of SRI, in different stages. Okay, for example, in the case of how much rainfall was received, everything was computed. So we did water budgeting basically, like we just we put a partial flume, we measured the water. We had, this is to measure the water from the canal into the field, and after it reaches the field, we used water tubes. So what this water these tubes were used with a controlling system where we can measure the water. And this is the water tube I was just saying, we implanted it inside and we just had measurements. When it was 10 centimeter below the soil also, there was a water. This is where from the plants take it through their root system. 10 centimeter depth, it just goes and takes the water from there. So the plant was not stressed. Even if it is, you can just see the cracks over here in the bottommost picture, you can just see the cracks over here, but still inside the water tube you can just see some water inside, right? So this is how we have perfectly managed the system. And we could see that the total number of irrigations in the conventional was 22, whereas it was 18 only in the SRI. So the total rainfall received was, during that period, it was 447 millimeters within 29 rainy days. So the total water, it was 1076, here it is 938 millimeters. So there was a 13% saving was observed, because it was, why this only 13%? In other places it was 40%. But here it was only 13%, because during the time of experimentation, we received around 450 millimeters of rainfall. That was common for both conventional and SRI. So even with that rainfall, over and above that rainfall also, we could achieve something around 13% increase in water use efficiency. Okay, so this is how the water use efficiency in SRI is perfectly, it is showing that it is very high as far as SRI is concerned compared to conventional method. So the another component technology is green manure application. This I've already presented. It was soil organic matter content was 0.9 and it was enhanced to 0.96. In Ponnanayar basin it was 0.86. It was enhanced to 0.95. Okay, so here I'm just showing other parameters with the green manure, without green manure. What is the percentage of change in Kalingrayan basin as well as in Ponnanayar basin? For dry matter is concerned, there is 19.5% enhancement in dry matter in Kalingarayan basin and it was 18.6 in Ponnanayar basin. The grain yield, there was 23% increase in grain yield in Kalingarayan basin and 22% increase in Ponnanayar basin. And similarly, the straw yield also around 10% increase in straw yield was also obtained. So just by adapting one component technology, you can increase the yield as well as the other parameters. So this is the perfect study on the methane emission and nitrous oxide emission with the different systems of rice cultivation. For example, SRI, alternate wetting and drying alone, conventional and direct wet seeding. So we followed 4 systems and we tried to analyze how much is the methane emission from this system. So the results were very encouraging, and it was saying that in the SRI as well as alternate wetting and drying system, we used this kind of experimental gadget. So we captured the methane emission through the Tetler bags and we analyzed through GC, and we could find that the methane emission as well as nitrous oxide emission, the total potential of greenhouse gas emission was very low as far as system of rice intensification and alternate wetting and drying. The next best was direct sowing, but conventional was actually letting out a lot of greenhouse gas emission. So to conclude, SRA requires less seed. It saves water to the tune of 10 to 47% with an average of 13%. Soil health is also improving, and then greenhouse gas emission potential is also very less. It produced more productive tillers, more number of grains, higher grain weight, and uniform maturity. So these are all the advantageous things which happened through SRI. The productivity of rice increased on an average to 27%, but there are few constraints. One is the time-bound operations. So the corner weeding, you have to do it on the 10th day, 20th day, 30th day, and 40th day, where it is very labor intensive, and that the operations are becoming a little cumbersome. So that's why people are not following that. So it is not possible in all the situations, SRI, especially in the old Delta region where cascading system of irrigation is coming out. The irrigation water comes from one field to another field, so you do not have any control over that, where you cannot practice SRI. Then another important issue is during the southwest monsoon time, you get rainfall with frequent rains with low pressure systems and cyclonic storms, in which you cannot practice SRI. So these are all the few constraints we have seen. So this is about the system of rice intensification. So if you have got any questions, we can discuss little later. I'll finish my second part of lecture as well. So the second important topic which I was asked to deal with is the crop boosters. You know, the crop boosters are mainly, it has been promoted from the crop physiology department. So the crop physiology department in Tamil Nadu Agricultural University is developing crop boosters for many crops. The very important crop booster which is very popular is the coconut tonic. Okay, what is crop boosters? First of all, the crop boosters are combination of nutrients and plant growth regulators, which has a very significant role in increasing the crop productivity, especially by maintaining the tissue nutrients and hormonal level at critical crop growth stages. That's how it is increasing the crop yield. That's why it is called as crop boosters. Let's see one after the other. So there are 6 crop boosters in practice now. The first one, as I said, it is TNAU, coconut tonic. Okay, the tonic with the nutrients and growth regulators for coconut. Especially now this is being practiced not only in Tamil Nadu but almost all over India. There are inquiries now from abroad also. Okay, so what it does, what are the benefits? One is it improves the photosynthetic efficiency. It decreases button shedding. You know, the button shedding is one of the major problem as far as coconut is concerned. It it is actually so much reduces the button shedding. Third one is it increases the number and size of the nuts. Naturally, with the less button shedding, the number of nuts are increasing. The size of the nuts are also increasing because of the balanced nutrients and growth regulated components. Nut yield is 20% increased, and then it is also it makes the plant resistance against pests and diseases as well as environmental stresses like drought. So these are all the benefits of coconut tonic. Okay, now you may ask me, what is the cost of this one? You have to just invest 10 to 12 rupees per tree. Okay, the cost of coconut tonic is 309 rupees per liter. It is a concentrated one, you get it. Okay, so what you have to do is you have to dilute it at the rate of 1:4 ratio. That means with 1 liter you have to add 4 liters of water. That means total fluids become 5 liters. Okay, with this 5 liters, what you have to do is you have to take 200 ml of this diluted liquid, and then you have to root feed it at the rate of 200 ml per palm. Okay, this has to be done twice a year with 6 months interval. So with 1 liter, approximately you get 5 liters. With 1 liter you can feed 5 trees. So with 1 liter of concentrate, you can dilute it and you can root feed it for 25 trees. That is the thing. So if you work out the cost for one time, you may have to spend 12 rupees. So per 1 year, approximately 25 rupees you are spending for one tree, but at the same time, the advantage you get is much more higher. The second crop booster is Pulse Wonder, TNAU Pulse Wonder, which is a very proven technology. Mainly in the pulses, flower shedding is one of the important issue. So with this, there is a decrease in flower shedding. The yield is increased up to 20%, and it also makes the plant drought resistant. Okay, so this Pulse Wonder is used for all sort of pulses. Right, so again the cost is rupees 210 per kg. The dose is 2 kg per acre. The spray volume is 200 liters. So 2 kgs you have to mix it in 200 liters and spray it at the time of peak flowering. So this is what is Pulse Wonder. The next booster is TNAU Groundnut Rich. This is specially made for groundnut, a booster with nutrients and growth regulators for groundnut. So here again the benefits are more flower retention, and then it improves pod filling. Especially the greatest advantage is bigger pod size, and then the more pod yield. Pod yield is increased up to 15%. In groundnut, 15% increase is a greater boon. Okay, it also improves drought tolerance. Again, the cost is 210 per kg. Dose is 2 kg per acre again. The spray volume is 200 liters, and then the stage of the spray is peak flowering and pod development. Here we recommend 2 times. In the case of Pulse Wonder, only once, because it is a short duration crop. Whereas groundnut, it is 90 to 105 days duration is the crop duration. So we recommend twice. One is at peak flowering, another one is at pod development stage. Okay, next booster is TNAU Cotton Plus. This is a booster with nutrients and growth regulators for cotton. So in the case of cotton, the major benefit is it reduces flower as well as square shedding. It improves bolt bursting, increases seed cotton yield up to 18%, it enhances drought tolerance in the plant. The cost is again 210 per kg. 2.5 kg per acre is the recommended dose. In the case of Pulse Wonder as well as in Groundnut Rich, it is just 2 kgs. Here for cotton, the dose is 2.5 kg per acre. Again in the same spray volume of 200 liters, twice at flowering as well as boll formation. So 2 times we are spraying, one at flowering, another one at boll formation. This is about the Cotton Plus. The next one is for maize crop. TNAU Maize Max. Again, this is specifically for maize. It improves the grain filling, and 20% increase in yield is there. It enhances the drought tolerance. The cost is 315 rupees per kg. The dose is 3 kgs per acre. Again, the spray volume is 200 liters. There are two kinds of spray. One is tassel initiation, another one is at grain filling. So this is the recommendation for maize. We have got TNAU sugarcane booster, the booster with nutrients especially for sugarcane. It enhances cane growth and weight. You know, it is a long duration crop and it improves the internodal length, which is an advantageous quality. It increases cane yield up to 20%. Sugar content is increased. Drought tolerance is enhanced. The cost is 368 per kg and application is 1.5 and 2 liters at 45, 60 and 75th day after planting. The spray volume is 200 liters. So 1 liter on 45th day, 1.5 liter on 60th day and 2 liters on 75th day. So 3 times spray is recommended with a spray volume of 200 liters at each time. So this is about the sugarcane booster. So totally we have got 6 boosters. Now we are also developing other crop specific boosters, but these are the 6 boosters: coconut tonic, pulse wonder, groundnut rich, cotton plus, maize maximum, maxim and sugarcane booster. These are the 6 boosters which are very proactively followed by farmers. Thank you so much, and